Hello guys, welcome back to my channel, Canada Knowledge Quest. As we know, in our channel we do justice to mathematics and engineering problems. Today we're going to continue on the topic trigonometry. I want to solve this trigonometric identity. We're told to prove that this must be equal to this. It's an identity to this. So all we have to do is just to try to simplify this expression on the left hand side to see if we can get this one on the right hand side. But it's an identity. And we're going to use some of the three identities we've established in our previous videos. For example, want to solve this, we know that secant theta is what? 1 over cos theta. And tan theta is sin theta over cos theta. So if we have known this fact, then we can simplify this using these expressions. Now, what do we do now? Let's simplify now. We have cos theta minus 1 over our sec theta is what? 1 over cos, which is reciprocal, geometric reciprocal of the cos, which is a 1 over cos theta plus tan theta is what? Sin theta over what? Cos theta. Then our plus have the same cos theta plus 1 over our sec theta is what? 1 over cos theta minus tan theta is what? Sin theta over cos theta. Now, what do we do next now? We can simplify this denominator. How do we do that? We can simplify it to can have that cos theta minus 1. I can take the LCM. So I take the LCM, I'm going to have cos theta. Cos theta and cos theta is 1 times 1 is 1 plus cos theta and cos theta is 1 times sin theta is what? Times sin theta plus, I'll do the same thing here, cos theta plus 1 over, and take the LCM, which is cos theta, the lowest common multiple. Then cos theta and cos theta is 1, times 1 is 1, minus cos theta divided by cos theta is 1 times sin theta. We're going to have sin theta. Now, so we have multiple fractions. So what we do, you can just take this one up. Now, can say, can have that cos theta minus 1 over, can put cos theta here in brackets because it's multiplying. Remember, if we have a over b over c, this can come down, this one can go up. So we're going to use the same technique here. Over 1 plus sin theta, then plus cos theta can come up here too. We have cos theta into what? Cos theta plus 1 over 1 minus sin theta. Now, if you have arrived here now, to simplify this further, we can take LCM in this part. Now, so how can we now do it now? Taking the LCM of this part, we have LCM is 1 plus sin theta and 1 minus sin theta. Now, this divided by this. We know that, let's take one by one. This can go in this. So we have this one left. Then we have cos theta. It's multiplying this and this. So we have cos theta minus 1 into what? This cancels this. We're left with this 1 minus sine theta. Then can close this bracket plus this divided by this. We're going to be left with this. Then cos theta is also multiplying. Put the bracket. So we have cos theta plus 1 into what? When this cancels this, we're left with 1 plus sine theta. 1 plus sine theta. Okay. Now, this and this is like when we have difference of two squares. But we're going to simplify it. First of all, before simplifying it, we can cos theta is common in both, so we can take one and do it. So let's click here to create space. Now, we have cos theta is common in the numerator. So we can say this is a cos theta minus 1 into 1 minus what? Sine theta plus cos theta is common there. Then we have cos theta plus 1 into 1 plus sine theta. Then we can close the bracket. Then our common denominator is what? 1 plus sine theta into what? 1 minus sine theta. If you're still watching the videos up to now, it means you're enjoying what we're doing. Do not forget to subscribe to our channels, like our page, follow for more. Now, what do we do now? I've told you this looks until we can work with difference of two squares. Now, let's try to expand it. We do it a long process. In expanding it, I have cos theta times 1 is what? Or let's say cos theta out first. This cos theta is common in between because it's multiplying the whole bracket. So we can open the bracket. Cos theta times 1 is what? Cos theta. Cos theta times sine theta is what? Is minus cos theta sine theta. Then minus 1 times plus 1 is what? Minus 1. Minus 1 times minus sine theta is what? Plus sine theta. Now, plus, let's open this bracket too. Cos theta times 1 is what? Cos theta. Cos theta times sine theta is what? Plus cos theta sine theta. Then 1 times 1 is what? Plus 1. Then 1 times sine theta is what? Plus sine theta. And close this bracket. Then let's try to open the denominator bracket too. Or let's first simplify this numerator finish, then we can work on the denominator. Now, opening this bracket, I have minus cos theta sine theta here, I have plus cos theta sine theta here, so it can cancel out. Then what do I have left? I have minus 1 plus 1. It can cancel out. Then I have what I have left. Remember, I've not taken my denominator yet. So I have cos theta. Now, and I have cos theta plus cos theta. That will be what? 2 cos theta. What else? I have cos theta. I have sine theta plus 2 sine theta. Remember, this cos theta is multiplying everything in the bracket. So I can now put my division and then multiply the denominator. Now, 1 times 1 is what? 1. Then 1 times minus sine theta is what? Minus sine theta. Sine theta times 1 is what? Plus sine theta. Then sine theta times minus sine theta, that will be minus sine square theta. And see, we have minus sine theta and plus sine theta, so it can go. So what do I have left? I have cos theta into what? 2 cos theta plus 2 sine theta, right? Over what? 1 minus sine square theta. Now, if you remember from our fundamental trigonometric identity from what we did in the last video, we know that 1 minus sine square theta equals to what? Cos square theta. Because we know that the first trigonometric identity we proved was that sine square theta plus cos square theta equal to what? 1. If I make cos square theta subject to formula, I'll have that cos square theta equals to 1 minus sine square theta. So I can replace this with what? Cos square theta. Let's do that now. So I have, let's go here. I have cos theta into 2 cos theta plus 2 sine theta, then over cos square theta. I can clean here to see. Let's try to finish the question up. Then I can now open these brackets. But before that, something is common in between. Or I can multiply it first. Let's multiply it out. I have 2, if I open this bracket, I have 2 cos square theta plus 2 cos theta and sine theta is what? Cos theta sine theta over what? Cos square theta. Now, we can see that 2 is common in between. So I can factorize 2 out. So I have 2 into what? Cos square theta plus cos theta sine theta over cos square theta. Now, remember in properties of fraction, we have that if we have A plus B over C, we can say A over C plus B over C. It's a valid property of fraction. So we can apply that same principle here. Now, applying it here, we have our 2 is outside, open bracket. Okay, we can still open bracket. We can say cos square theta over what? Cos square theta plus cos theta sine theta over what? Cos square theta. Now, cos square theta divided by cos square theta is what? 1. So I can come here and say 2 into bracket 1 plus, cos square theta divided by cos theta is 1. Anything divided by itself, it's 1. Now, I have cos square theta. I have 1 cos square theta here, and I have 2 cos square theta here. So 1 cancels out. So I'm left with what? Sine theta over 1 cancels 1 here. So I'm left with cos theta. Now, what is sine theta over cos theta? Tan theta from our basic trigonometry. So that will be 2 into 1 plus tan theta. And that gives us the final answer. So we're able to prove that this trigonometric expression is identical to this expression. So you can see from the video, what we do is just to simplify the left-hand side of the equation to its simplest form using the reciprocal of the trigonometric ratios. And you can, from knowing the reciprocal of trigonometric ratios, you can easily solve various questions for today. So if you found this video very useful, do not forget to follow our channel, like our page, subscribe for more beautiful contents. Thanks for watching.